This is a retest on the Fantom Icon 17.5 turn and the SMC LowRider 17.5 turn, just to compare them once again, this time with the Fantom, the tuning pins, and without the tuning pins. And I'm using the MiniPro Dyno as well to get graphs showing efficiency, torque and power, just to see if there's any differences between the Fantom Icon pins, no pins, and comparing it to the SMC 17.5 turn. The Fantom part number FAN 19317S 17.5 turn Icon Prospect motor, tuned to, well, near enough 6 amps. I just done with the tuning pins in, giving you a kV of 3365, and the RPMs at 7.9 volts would be 26585, and that is with a timing of average of 46. Very tight sender board, 46, 46, 47. Taking the tuning pins out of the Icon motor, there they are, stuck them on this rotor here. And I've also taken out the tiny grub screws that into the front face. The magnetic rods I've taken out. Now that is the reading 3419 that I got. I just retested the motor. That was before I took the tuning pins out, so I left it. So now I'm just going to reassemble. Didn't touch the timing. Just going to recheck. It's just put the charger on and make sure the battery's fully charged. The current's gone up as well as the revs, so it's like it's made quite a difference. There we go, 3582. So yeah, quite an increase in RPM. The timing reading, see if it's changed that. And the timing 47 average with a 48, 46, 47, which I think was the same as before. I didn't change the timing on the M bell, which is below the middle, between 40 and 50. So removing the tuning pins makes quite a big difference to the RPM. Torque wise, well, the rotor hasn't changed. Removing the tuning pins also gets the weight of the motor down. Only weighs 141 grams now, saving of over 5 grams with the new SMC LowRider version 3.3 stator, 17.5 turn. So just weigh it, 136.8 grams, pretty light. The Fantom 17.5 Icon, the tuning pins, with tuning pins weigh 145.6, with the tuning pins taken out weighs 141.0. Both very lightweight, but the SMC is the lightest. Testing the SMC 17.5 turn motor in stator resistance. 0, make sure the low resistance meter is zeroed. Then we can connect up A, B or C. 035 is pretty good. Good as anything we've measured so far. Middle one, 035. The last pole, 035. That's even slightly perhaps just below. That's pretty impressive. The previous ones, the best one we measured was the R1 was similar. 2035s and 1034, and the Surpass one was only 0.036. Outlaw 17.5, which has got an illegal extra low resistance wind, was only 0.034 all the way through, so that's very impressive. I would just double check the Icon 17.5 turn. Last time about 0.037038, C037038 was correct the last time I measured it. The SMC tuned to 6 amps, very impressive, 3587 kV, and that is almost the same as what I got with when I just done the Fantom without the tuning pins in. I got a 3582 timing, average 45 degrees, 45, 44, 46, so slightly less timing than the Fantom, which was a 47, 48, 46, 47, but very similar. Timing on the M bell for the SMC is about 48, so in the Fantom 44, taking out the steel rods on the pins, tuning pins on the Fantom made a huge difference. I'm wondering if we can take a couple of these screws out and hold it together and see if it makes any difference. I'm going to do that. Taking all three screws out that hold the SMC together to retest the kV, see if it makes any difference. I'm going to have to hold the motor together and make sure that it's doesn't vibrate apart, and then I'll just do the kV test, holding it together. Well, it's jumping about a bit because it's not clamped up, but it was a bit difficult to hold together. It doesn't seem to have made any really significant difference. It was 3587 with the pins in. So it looks like they've got that pin arrangement correct. I'll just double check the timing. With all three pins out, the timing really didn't change. It's 47, 46, 46, which is 1 degree more than when I tested before, but that might be just because it's not clamped up. So the conclusion on the SMC is that you don't need to take the pins out that hold the whole thing together, these ones, as they don't affect the performance at all. To position the screws on this SMC in a different place to other motors, they've got it in the center of between the coils. You can't really see, the coils are there and there, and it's in the center, where others, they have the screw above the middle of the coil. So they've obviously found that has less effect than having it above the center of the coil. If you look at the Fantom, where the screws would go through, you can see the coil is there, and that's where most manufacturers, if not all others I've ever seen, have the screw there. They've obviously found something. The screws in are good. They've obviously done their homework on how to assemble this motor and tune it to the maximum performance, so that's pretty impressive. You don't need to take the screws out of this SMC motor. The gauss of the motor from the rotor taken out of the SMC 17.5. The 1460 minus 1480. So average around about 1470 odd. The Fantom was a pretty strong rotor, over 1548. And the previous SMC I tested was the 13.5, also about 1475. So they've gone with that rotor strength compared to others such as the R1 and the Surpass. The R1 V21, about the same as theirs. Theirs was a 1460 something, but the Surpass was quite strong. It's over 1500, and 1520, 1530 average there. Comparing the design of these two stators between the SMC and a conventional stator, the conventional one had the channel for the screw above the leg, causing a pinch point here where it's very thin for the magnetic flux to pass through. Now this is quite an old one. They're a bit thinner now on some of the modern motors. With the SMC, they've put the channel in the middle here, and that's so sensible, because there's a gap in the middle where there's no wire, so they can have the, I don't know if I can see it, it goes down to allow the channel, so this sweeps, instead of being pinched off there, it sweeps down and up again without losing any of the stator material or choking off the magnetic flux. It goes down and up. That's brilliant. Why the manufacturers never did that in the beginning is beyond me. It makes perfect sense. It's taken all this time for SMC to work it out, and it's allowed them to have a nice straight leg. This is an old one. Some of the modern ones, this is because it's pinched in there to come round, they can't wind it tight at this point, but with this one they've got a nice straight leg, and they've managed to wind the windings on so tight and get them, it's so tight and so short. That's a class leading low resistance winding. But the point is the channel, they've moved the channel around. Virtually every other motor has still got that channel in that position, including the latest Fantom icon. You can see that the screw would go down there and the coil is there. So it's like this one, it's where the coil is, as opposed to this one where it's not where the coil is. Very clever indeed. They've done good, these guys. Results of testing the Fantom Icon 17.5 and the SMC LowRider 17.5 on the MiniPro Dyno. I've got a number of graphs that I've recorded. We can just show the difference between them. The SMC is as it comes. The Fantom, I've done two tests, one with the pins in and one with the pins out, just to see what the difference is. A graph showing the power output and the torque output of these motors, and the torque according to this is the blue one with the pins in for the Fantom, and the SMC is almost identical, and with the Fantom no pins, the torque is less. Okay, so it's a bit angular, but it is definitely less. We're looking at the other graph below it is the power output. They're pretty similar. The two highest ones for the power output are the Fantom with the pins and the SMC, almost identical, and the purple one is the Fantom without the pins. It's slightly less power. They all tail off about the same, but just initially when it's accelerating, slightly less power there, but it seems to have a little more power, a little steeper at the beginning, and that's the Fantom with no pins. Now let's look at the efficiency curve. Efficiency versus RPM. The green one at the top is the SMC efficiency, and the other two are the Fantom with the pins in and out. As I said before, the efficiency seems to correlate directly with the winding resistance. The lower the winding resistance, the better the efficiency, and the green one, the SMC's got very low winding resistance and it's got the best efficiency. Flattens out about 57%, and the slightly higher winding resistance, because that's where most of the losses are in the winding resistance, and it comes up exactly just over 50, about 51%. Now the efficiency curve will also show you best place to gear your motor on a big fast track, and they're all about the same. Go over the top of the efficiency, down the other side, and you don't want to go any further than here, just generating heat. That's about 20,000 RPM. They're all very much the same. The green one, SMC, perhaps this stretches out a little bit more, but nothing in it. You don't want to go any further than that. Next we look at the acceleration. The acceleration graphs for the SMC and the Fantom with and without pins, slightly confusing. The line along the middle is just the voltage to show that the input voltage remains constant. We can take that off so that they're all tested the same. These are the current amps drawn. I'll just take them off for now. Leaving the three curves, I've got 15%, 50% and 100% acceleration, and the time runs from 0 to 12 seconds on acceleration, and there's a time for braking, 100% brakes. The first part right up to here, they all seem to be the same, so let's look at the RPM achieved. The blue one is the Fantom with the pins, the green one is the SMC, and the brown one is the Fantom without the pins. And you can see that by taking out the pins, there's a noticeable increase in RPM. These have peaked out at 23 and a half, just under 24, but the Fantom without the pins has now achieved nearly 25,000. So an improvement from the blue point, 23.5, to 25,000, which is a noticeable increase in revs for the Fantom. As I said, the acceleration time here is the same, and these start peaking off, and the Fantom is still pulling up to a higher RPM. These are flattening off, and that's about starting to flatten off. Another thing to notice is the brake. The steeper the curves, the better the brakes. The SMC, the green curve, has the best brakes. It's steeper than the others. And then the Fantom, they're pretty good brakes, but the blue one with the pins is slightly less braking force than the one when the pins are taken out, which is a bit odd. But they've all got pretty good brakes, they're pretty close. So conclusion, well, the Fantom has got more revs. Let's just look at the current drawn. Fantom with the pins, current draw there. Let's do the Fantom without the pins. Slightly less current for the same acceleration initially, and then the current's higher, so slightly different characteristic. And the SMC, similar to the pink one, which is the Fantom with the pins. Conclusions from this: there's not a lot of difference early on in these motors, but the Fantom without the pins definitely pulls more RPM. At top end it's going to be faster. A claim that for their insane RPM seems to bear it out. Final conclusions about the Fantom Icon and the SMC LowRider. They both have claims about high RPM and other claims about their motors. And it's pretty much borne out. They've got very high RPM. The Fantom Icon with the tuning pins out has got much higher RPM than with them in. Otherwise, the SMC and the Fantom are about the same. And as far as the rest of the results go, it's interesting to note that testing it on my normal tester, that the kV on the Fantom jumps a lot by taking out the tuning pins. From a 3378 it goes up 3582, almost 200 kV extra, and without changing the timing. We looked at the resistance before. The SMC is now the class leader with the R1, for instance, on resistance. Stator resistance on the Fantom a little higher, and that showed up in the efficiency test where the SMC has got a bit of better efficiency, so it's going to run a little bit cooler. The weight, well, the SMC is very lightweight, but when you take out the tuning pins of the Fantom, it's not far behind. Otherwise, they're both very good motors indeed. They compare very well now to the 17.5s that I've shown before. The R1 weighed 143 grams. Surpass was a little bit heavier, 153, so they're well ahead of that now. The kV are similar to the Surpass Red and the R1. Overall, both are very good motors. The Fantom without the pins in and the SMC. These motors are really just eking out the last little bits, and they've succeeded.